Welcome to using the alternating series test. So recall that the alternating series test states that if the sequence A sub n is positive, monotonically decreasing, and the limit as n goes to infinity of A sub n is equal to 0, then both the sum from n equals 1 to infinity of -1 to the n times A sub n, and the sum from n equals 1 to infinity of -1 to the n plus 1 times A sub n. Both of these converge. So our job here is to prove that the alternating harmonic series converges. So the sum from n equals 1 to infinity of -1 to the n times 1 over n. Technically, this is the negative alternating harmonic series, but same idea. So we want to prove that this converges. So note, if we take A sub n to be 1 over n, then we have the A sub n's are positive, and A sub n plus 1 is less than or equal to A sub n. So we meet our conditions. Furthermore, the limit as n goes to infinity of A sub n is the limit as n goes to infinity of 1 over n, which is 0. So we can apply the alternating series test. So by the alternating series test, we have that the sum from n equals 1 to infinity of -1 to the n times 1 over n. This must converge. Right. So note again, just because an alternating series converges doesn't mean that the series with all positive converge. Right. So just a quick note. The sum from n equals 1 to infinity of 1 over n diverges, right? So, well, essentially, just because so since this sum diverges, essentially what we have is that the limit of n going to infinity of A sub n equaling 0, right, does not guarantee, so does not give convergence of the sum from n equals 1 to infinity of A sub n, right? This just holds for alternating series that are decreasing at the end, right? So this just holds for alternating series that are essentially, that have A sub n monotonically decreasing. So that have A sub n eventually monotonically decreasing. So in the next video, we'll see some things to watch out for. Make sure that we do meet the conditions of the alternating series test.